Hello, and welcome to Project 3.2.1. This project covers the clock and program counter and also the code of the CHUMP computer. When power is provided to the clock circuit, the A-stable full auto 555 timer begins a clock pulse at a steady rate. This square wave is dependent on the resistance value provided by this potentiometer and this capacitor. As the resistance value increases, the frequency of the clock signal diminishes. The second 555 timer is the monostable mode. When the user presses the button, the output is switched on for a moment of time until the capacitor can discharge, in which the output is set low. The third 555 timer simply selects between the two other 555 timers for which clock pulse will be sent into the program counter. With each rising edge of the clock pulse, the 74LS161 4-bit binary counter increments. This is our CHUMP computer's program counter. As the clock increments, we want the program counter to also increment by 1. Beside the program counter are 4 dip switches. These dip switches can be set to the desired number you want the program counter to jump to. Once the desired number is entered, for example 4, the NAND gate that's connected to load must be set high, giving a low signal to the load pin. Having a low present on the load pin of the program counter switches all of the outputs to the inputs on the next available clock pulse. So if I hold these two buttons and select the next clock pulse, we should see all of the inputs, which are at 0000, result in the outputs. So if I hold these two, press 1, boom. The outputs went to the inputs, and the inputs are all selected to 0000. I can select 4 and then do the same thing. And there we go. It jumps right to program count number 4. The program counter can select between 0 and 15 as it is a 4-bit number.